Thank you. In the next few minutes, you will understand why differential equations of this form are referred to as homogeneous linear constant coefficient second order differential equation, and also you will understand how to form the auxiliary equation. Now, equations of this form are said to be homogeneous because they equal to 0. So they are homogeneous because they equal to 0, and they are linear because the y term is of the first degree, and they are constant coefficient, linear constant coefficient, because they are always expressed in this form. And they are second order because the second derivative is of the highest degree there. So how do we form the auxiliary equation? Well, we want a solution of this differential equation that when we find the first derivative and the second derivative, it hardly changes such function. So let us try, say for example, y equals e to the lambda x. Equations of this form, when you find the first derivative and second derivative, they hardly changes the function. So let us choose a solution for y equals e to the x there. Now let us find the first derivative. So we have dy by dx equals to lambda e to the x, e to the lambda x. And the second derivative, let's find the second derivative there. We get lambda squared e to the lambda x. What we're going to do, we're going to substitute these values back into the differential equation here and see whether we can get a solution. So the second derivative we have here is this, and we're going to substitute it back in there. So we're going to have a times lambda squared e to the lambda x plus b times dy by dx is just lambda e to the x, e to the lambda x, plus c times y, and we know that y is e to the lambda x. Okay, so what we note here is that e to the lambda x is a common factor, so let us factor out e to the lambda x. So we have e to the lambda x into a lambda squared plus b lambda plus c, and that equals 0. Now, for y to be a true solution of this differential equation, for y equals e to the lambda x to be a true solution of the differential equation, it means that a lambda squared plus b lambda plus c must equal to 0. So let's just write that. So for y equals e to the lambda x, this is a true solution of the differential equation. Therefore, a lambda squared plus b lambda plus c equals 0. And this equation here is called the auxiliary equation. So we have now derived the auxiliary equation, and this equation is very unique because the solution of this equation here gives rise to the general solution of the differential equation. So in the next clip you will understand how to find the general solution of differential equations of this form.